1 minute ago, something impossible appeared on one of Europe's most dangerous volcanoes. A massive fracture has opened near Mount Etna's summit. The crack sits at 3,000 meters elevation, carved deep into the southeastern crater complex. Scientists monitoring the volcano say this is not weathering, not erosion, not the typical thermal cracking that follows every eruption. This is structural failure. The fissure cuts clean through layers of solidified lava and volcanic ash. It runs for dozens of meters, wide enough to swallow a person, deep enough that thermal cameras detect heat rising from within. INGV observers who flew over the site describe it as a wound in the mountain itself. Is this the beginning of Etna's long-predicted flank collapse? Could the entire southeastern slope slide into the Mediterranean? And why is this fracture appearing now after months of violent eruptions that reshaped the summit itself? The mountain rises 3,403 meters above the Sicilian coast, a black volcanic giant dominating the skyline for hundreds of kilometers. Its summit trails steam even on calm days. At night, the glow from active vents paints the underside of ash clouds in shades of orange and red. Below its slopes, the city of Catania spreads outward toward the Ionian Sea. Nearly 300,000 people live in the city proper. The greater metropolitan area holds over 1 million residents, packed into towns and villages that trace the volcano's lower flanks. They wake each morning to the sight of Etna's smoking peak. They breathe air tinged with sulfur when the wind shifts south. Most have learned to live with the volcano's moods. Ashfall is swept from balconies, earthquakes are noted and then forgotten. The fertile volcanic soil produces wine grapes, pistachios, and citrus that feed the local economy. But this is different. For decades, satellite measurements have tracked a slow, relentless movement. Etna's southeastern flank slides toward the Ionian Sea at a rate of several centimeters per year. GPS stations bolted into bedrock, laser rangefinders aimed at reflectors on the slopes, and radar interferometry from orbiting satellites all confirm the same disturbing pattern. The data comes from multiple independent sources, cross-checked and verified year after year. The entire eastern side of the volcano is on the move. The numbers are small but relentless. 3 centimeters one year, 4 the next. The displacement compounds. Over a decade, the flank moves tens of centimeters. Over a century, meters. The ground beneath towns like Zaffarana Etnia and Santa Venerina is creeping seaward while residents sleep. But the ground had one more secret. The fracture appeared roughly 1 month ago during routine monitoring flights. Observers at the Italian National Institute of Geophysics and Volcanology, INGV, spotted the clean break cutting across volcanic deposits near the southeast crater rim. The fissure runs wide and deep, not the hairline cracks that form during typical cooling. This is structural tear. It sits at the exact location geologists have warned about for years. The southeastern flank is not just moving, it is detaching. Etna's base rests on unstable sediment and fractured basement rock. Gravity pulls the massive volcanic edifice seaward, while magma pressure from below destabilizes the interior. Every eruption, every intrusion of molten rock pushes the flank further toward a tipping point. The new fracture lines up perfectly with predicted slip planes. Scientists have modeled this failure zone for decades. Now the mountain is following the script. The southeastern flank is more than just unstable ground. It is a slow-motion landslide, a creeping mass larger than Manhattan sliding beneath the waves. In 2018, researchers from GMR Helmholtz Center for Ocean Research in Germany and INGV deployed an acoustic geodetic network off Etna's coast. The mission required specialized equipment and months of planning. They placed 5 acoustic transponders on the seafloor at 1,200 meters depth, straddling the offshore extension of the flank boundary fault. Each transponder was equipped with absolute pressure sensors and acoustic ranging systems. The devices communicated with each other every 90 minutes, measuring distances with millimeter precision using sound waves traveling through seawater. The data revealed something unprecedented. Within 8 days in May 2017, the submerged flank slipped more than 4 centimeters eastward along the fault. This was not gradual creep. It was a sudden, discrete event, On land, GPS stations recorded similar displacement at the same time. Coastal monitoring sites showed the surface moving in concert with the seafloor. But here is what changed everything. The movement was largest offshore, far from the magma conduits at the summit. Displacement actually increased with distance from the volcanic center. If magma pressure were driving the slide, displacement would be greatest near the summit where intrusions push outward. Instead, deformation increased toward the sea. The pattern was unmistakable. This was gravitational collapse, not volcanic inflation. The massive weight of the edifice, perched on unstable sediment and fractured basement rock, was pulling itself apart under its own mass. The conclusion was inescapable. Gravity, not magma, is the primary force pulling Etna's flank toward catastrophic collapse. The 4-centimeter slip released energy equivalent to an earthquake between magnitude 4.3 and 5.3. Yet the seismic network detected nothing. No large earthquake accompanied the movement. The fault slipped aseismically, silently, releasing stress without the warning signs that usually precede tectonic ruptures. The volcano is not just erupting, it is coming apart.
Throughout 2024 and into 2025, Etna unleashed a relentless sequence of eruptions. The Varajan crater, one of the summit's central vents, produced towering lava fountains reaching 2,000 meters above the rim. Incandescent jets of molten rock arced through the night sky, visible from towns dozens of kilometers away. Ash plumes climbed as high as 9.5 kilometers, punching through the troposphere and spreading across the Mediterranean. Catania Airport closed repeatedly. On July 4, 2024, ash blanketed the runways. Passengers were stranded. Flights were diverted to Palermo, hours away by road. The airport reopened the next day, only to close again on August 15th when another massive plume drifted south. On June 22, 2025, a partial collapse of the southeast crater's northern flank triggered a pyroclastic flow that raced down the Val del Bove. A churning mass of superheated gas, ash, and rock fragments roared down slope at speeds exceeding 100 kilometers per hour. The temperature at the core of the flow exceeded 400 degrees Celsius. Tourists hiking near the summit heard the roar and ran. Videos captured people fleeing, looking back at the dark clouds surging behind them. The flow stayed within the Val del Bove, a natural drainage carved by ancient collapses. No one died. But the message was clear. Each eruption weakens the structure further. Magma intrusions fracture the interior rock. Gas pressures build in pockets beneath the summit, then release explosively. The southeast crater, born in 1971 as a small pit, has grown into a massive cone that now challenges the older summit craters for dominance. But recent collapses have left it fractured and unstable. The rim is jagged. New cracks appear after every paroxysm. Seismic analysis reveals thousands of microquakes clustering along a newly identified ring fault encircling the caldera. These tremors, many too small for conventional networks to detect, were mapped using artificial intelligence trained to recognize patterns in continuous seismic data. They trace pathways where stress concentrates, where the rock is failing incrementally, where the next large rupture might begin. The volcano's internal architecture is fracturing from the inside out. But this was only the first warning. In the shadow of the volcano, life continues with a strange mixture of normalcy and vigilance. Maria Greco, a school teacher in Catania, watches the summit each morning from her apartment balcony. She has lived here her entire life, 53 years under Etna's gaze. The eruptions of 2024 painted her neighborhood in ash 3 times. Each time she swept the rooftops and balconies, rinsed the cars, and waited for the next one. "We know the volcano can do more than this," she says, her voice steady, but her eyes tracking the steam rising from the craters. "We know the volcano can do more than this. My grandmother told stories of the 1669 eruption, when lava reached the sea and destroyed villages. We remember, but we also live." Her words carry a weight that statistics cannot capture. The people here are not naive. They understand the risk, but Etna has shaped this land for millennia, creating fertile soils, geothermal energy, and a tourism economy worth millions. Leaving is not an option for most. Staying means living with uncertainty. The hardest part is knowing that one day the mountain will decide, not them. If the southeast flank collapses catastrophically, the sequence of events would unfold with terrifying speed. A landslide of billions of cubic meters of rock would crash into the Ionian Sea. The volume would dwarf historical examples. The sound would be audible across Sicily. Seismometers across the Mediterranean would register the impact. The sudden displacement of water would generate a tsunami radiating outward in all directions. Wave heights near the shore could exceed 10 meters, enough to inundate coastal communities within minutes. The first wave might arrive before sirens could sound, before evacuation orders could be issued. Fishing boats would be swept inland, port facilities would be destroyed, coastal roads would vanish beneath the surge. But the tsunami is not the only threat. The collapse would instantly release pressure on the magma chamber beneath the flank. For years, the weight of the flank has acted like a lid on a pressure cooker, containing the volcanic gases dissolved in molten rock. Remove that lid, and the magma depressurizes explosively. Like uncorking a champagne bottle, the sudden release triggers violent degassing. Magma froths, expands, and accelerates upward through the conduit. What emerges is not lava, but a superheated mixture of gas, ash, and pulverized rock. Lava surges, pyroclastic flows, and ash plumes would blanket the region. Flows could reach the sea within minutes, generating additional steam explosions. High-altitude ash would disrupt aviation across the central Mediterranean, affecting routes over Italy, Malta, Greece, and North Africa. Flights would be grounded for days, possibly weeks. Catania, sitting directly in the shadow of the sliding flank, faces the greatest danger. Entire neighborhoods built on previous lava flows could be buried or swept away. The port, the airport, and critical infrastructure would be crippled or destroyed. Emergency response would be overwhelmed. Hospitals would fill beyond capacity. The economic and human toll would be catastrophic. Historical records offered grim precedents. In 1669, lava flows from Etna reached the sea after destroying 10 villages, but a flank collapse would be orders of magnitude worse. Scientists compare the potential event to the 1888 collapse at Ritter Island in Papua New Guinea, which generated a tsunami that devastated coastlines hundreds of kilometers away. Scientists cannot predict when such an event might occur, but they can no longer exclude the possibility. The entire slope is in motion due to gravity. In response to the fracture and escalating activity, Italian authorities have tightened access restrictions. Since July 2024, hikers can only ascend above 2,750 meters on the southern slopes if accompanied by licensed alpine or volcanological guides. On the northern side, the limit is 2,850 meters. The summit zones, including areas above 3,000 meters, are heavily restricted. Only authorized scientific teams and certified guides with special permits can approach the active craters. Roads leading to the upper slopes are closed during periods of heightened alert. Municipal ordinances can change within hours based on real-time assessments from INGV. What is open today may be forbidden tomorrow. INGV has intensified monitoring to levels unprecedented in the volcano's history. Seismometers buried in boreholes track every tremor, from magnitude 0.5 quakes down to microseismic events barely detectable above background noise. Tilt meters measure ground deformation with precision measured in microradians. Gas sensors sample emissions from summit vents, analyzing ratios of sulfur dioxide, carbon dioxide, and hydrogen sulfide. Thermal cameras watch for heat anomalies that might signal magma approaching the surface. Satellite radar measures millimeter-scale displacement from space, creating interference patterns that reveal how the ground deforms between satellite passes. Drones equipped with multispectral cameras survey the summit craters, documenting changes in morphology and thermal output. Yet even with all this technology, the volcano keeps its secrets. During the November 2024 eruption, cloud cover blocked visual observation for days. Instruments detected rising tremor and ash emissions, but observers could not see which crater was erupting. Webcams showed only gray mist. Field teams could not reach the summit safely. Only after the weather cleared did volcanologists confirm the source. Etna operates on its own schedule, often hidden behind weather or nightfall. The Civil Protection Department coordinates emergency plans with local municipalities. Evacuation routes are mapped and regularly updated. Shelters are prepared in schools and public buildings. Emergency supplies are stockpiled.
but the sheer number of people living in the hazard zone complicates everything. Moving 1 million people quickly is nearly impossible. Simulations show that a full evacuation of the red zone would require days under ideal conditions, but ideal conditions do not exist during volcanic crises. Roads would be jammed, panic would spread, infrastructure might fail before evacuation completes. Among volcanologists, debate continues about the true timeline and nature of the threat. Some argue that the flank has been sliding for thousands of years and could continue for thousands more without catastrophic failure. Small episodic movements release stress gradually, preventing sudden collapse. Others point to the 2018 underwater data as evidence that the system is accelerating. This kind of failure can happen without warning. Dr. Morelia Ulab, who led the seafloor geodetic study, stated clearly that catastrophic collapse cannot be excluded. Professor Hydron Kopp, coordinator of the monitoring network, emphasized that the entire slope is in motion due to gravity, making a Mediterranean-wide tsunami possible. However, she also acknowledged that prediction of when such an event might occur is beyond current capabilities. The uncertainty is the hardest part. Scientists know the flank is moving, they know gravity is the primary driver, they know the system is destabilizing, but they cannot say if collapse will happen in 10 years, 100 years, or 1,000. The volcano does not offer deadlines. The impacts extend far beyond the immediate blast zone. Catania Airport, the 5th busiest in Italy and the largest in southern Italy, sits less than 35 kilometers from the summit. During the August 2024 eruption, ash plumes forced a complete shutdown. Hundreds of flights were canceled or diverted to Palermo. The airspace is divided into sectors centered on Mount Etna. When ash drifts into specific sectors, air traffic control closes affected arrival and departure routes. Variable winds make forecasting difficult. A red aviation alert can last for days. Tourism, which generates substantial revenue for the region, suffers during prolonged eruptions. Hotels cancel bookings, guided tours are suspended, the economic ripple effects spread across Sicily. But tourism is only part of the equation. Etna's ash coats agricultural fields, reducing crop yields. The fine particles damage machinery, clog filters, and contaminate water supplies. Repeated ashfall disrupts daily life in ways outsiders rarely consider. And if the flank collapses, all of this has become secondary. The primary question shifts from inconvenience to survival. Right now, more than 500,000 people live within direct reach of Etna's power. They occupy one of the most dangerous volcanic hazard zones on Earth. The southeastern flank slides toward the sea at measurable rates documented by multiple independent monitoring systems. Underwater geodetic networks have recorded sudden, aseismic fault slip offshore, proving the movement extends beneath the waves. Recent eruptions have reshaped the summit craters and triggered collapses that left the southeast crater fractured and unstable. Thousands of microquakes trace the outline of a ring fault system that encircles the sliding mass. Thermal anomalies, gas emissions, and ground deformation all point to a system under extraordinary stress. All of this is documented fact. What remains unknown is the timeline. Scientists can track the movement, measure the deformation, and model the collapse scenarios with sophisticated computer simulations. They can estimate wave heights, runtime distribution, and potential casualties, but they cannot predict the tipping point. The transition from slow creep to catastrophic failure remains hidden in the volcano's internal mechanics, buried kilometers of fractured rock. Etna's flank will collapse. The only question is when. Geologic time operates on scales that dwarf human lifetimes. 1,000 years is an instant. 10,000 years is a blink. The volcano has been active for 500,000 years. It will be active for hundreds of thousands more. The flank collapse, when it comes, will be just another event in a long history of destruction and renewal. But for the people living in its shadow, the when matters. It is the difference between a peaceful life and sudden catastrophe. It is the difference between evacuating in time and being caught in the path of a tsunami. It is the difference between preparedness and panic. And until that moment arrives, the people of Catania, the farmers on the slopes, the fishermen along the coast, and the tourists drawn to the volcano's raw beauty will continue living under a mountain that is slowly, inexorably pulling itself apart. The fracture is not just a crack in the rock, it is a warning written in stone, a glimpse of the forces building beneath the surface. The volcano has shown its hand. The southeastern flank is detaching. The underwater fault is slipping. The summit is fracturing. The question is whether anyone can read the signs before the mountain decides to act.
Will the next earthquake swarm signal the beginning of the end? Will the next eruption trigger the cascade that scientists have modeled for decades? Or will Etna continue its slow slide for another generation, lulling residents into complacency before the final catastrophic failure? The volcano knows the answer, but it is not telling.